Okay, so this problem wants you to graph mass versus volume for the data that's given in this table here. After you make this graph, you want to also figure out the slope of the line. So first, let's just start by making our graph. It says graph mass versus volume, so we'll put mass on our x-axis and volume on our y-axis. So we'll call this volume in centimeters cubed, and we'll call this mass in grams. So our mass has a highest value of around 70.1, so you can just kind of break up the increments. Doesn't really matter how you do this. The way that I'm going to do it is just go by increments of 25 on the x-axis, and for the y-axis, because we have a value of 22, we can just go in values 5, 10, 15, 20, 25. So let's do 5, 10, 15, 20, and 25. And ideally, these increments should be equal and not like I drew them, but we don't have graph paper, so we're going to make do with what we have. Okay, so now let's make our graph. So we have a mass of 24.1 and a volume of 7.5, so that point would be approximately here. Then we have a mass of 5 and a volume of 12, so the point is approximately here. Then we have 48 versus 15, and finally we have 70.1 and 22. And so now if you look, there's a nice positive correlation between our graph. And that is not a very good line of best fit. It should be up a little bit, but again, I don't have graph paper or a ruler, so you make do. But I think you get the picture. So now the question also asks you to figure out what the slope is from these values. So if you remember, the equation for the slope is going to be your change in y over your change in x, which is also going to be a good way to remember that is it's going to be rise over run. So for these problems, it doesn't matter which points you choose. So you could choose points 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4, essentially any 2 points you want. So for me, I'm just going to choose the first 2 points, kind of make it easy. So we're going to look at the slope defined by these 2 points. So our first point is we have an x value of 24.1 and a y value of 7.5. And if you draw or write in your points, it's really important that you do write your x value first, followed by a comma, and then followed by your y value. So for your second point, it's 38.5 and 12. Okay, so now we can use these values to figure out the slope. So your slope is going to be equal to your change in y. So it doesn't matter if you go in which direction you go, because if you go, so you can either go 12 minus 7.5 over 38.5 minus 24.1. So if you were to go in the opposite direction, you would have 7.5 minus 12, 24.1 minus 38. You would have a negative number divided by a negative number, which would become a positive number. And in this case, we have a positive number over a positive number, which when you divide it becomes a positive number. So it doesn't matter in which order you do this, you do just want to make sure that you go specifically from y2 minus, that you use the same values for each. So for example, this is y2 minus y1, and this is x2 minus x1. Okay. So x2 minus x1 and y2 minus y1. So when you multiply or you subtract these numbers and then divide them, you get an ultimate slope of 2.82. So your slope might vary slightly depending on which numbers you use, but because it seems like these points have a really good correlation, it shouldn't vary too much. So again, if the question doesn't specify which is your y-axis and which is your x-axis, it doesn't really matter which one you put where, though if it says, like this problem mentions mass first, probably helpful to put your mass on your x-axis. Then you want to plot your points. Your red line is your line of best fit, which is also your slope. And so your slope is going to be defined by your rise over run, and in this case your slope is 2.82.